What's going on, YouTube? I'm fixing the car today. As you guys know, we got a broken guide and we got a Fubard turbo. So going to be ripping her all down, getting ahead to Jeremy, have him fix the head up, check the valves, probably end up doing new valves. And then I think the turbo is gonna be going to Boost Lab. They said they can hook me up, give me a new turbine, get her all freshened up. So I think we're gonna do that. So I'm gonna rip this head off. You guys have seen this a million times. I'm not gonna really film it, but I'm gonna show you guys, once I get the head off, the damage, and then I'll show you guys the cylinder wear that we are getting again. And number one is getting it again. This is what we've been trying to avoid. Like I said, we put oil squirters in. We did a coarser hatch hone with our ball hones, and still getting wear in the number one, like pretty much on the exhaust side. But it's not affecting the leak down. It's not affecting compression. We get great comp numbers and we get great leak down. It was less than 5%. So it's like, it doesn't seem to really be affecting the ring seal, but it is smoothing the hatch off. So I don't really know what else we can do. I don't know if it could be possibly piston design. Maybe it just needs more fuel in that cylinder. I did notice one seems to always be hotter than the rest. So I did end up putting more fuel in number one for the race at Summer Duck. We're not really gonna know if it did anything hatch-wise because it's already wore off, but I'm gonna keep that extra fuel in that cylinder, see if it gets worse. If it gets worse, then we know it's really not the fuel. So I'm just not sure, but I'm gonna quit stressing over it, because if it doesn't affect seal and it doesn't affect compression, I'm just gonna run the car. And then every season I'll just hand hone it, put new rings in it, and send it again. So we'll see what happens, but let's get this head off. So here's our damage. As you guys can see, really messed up the turbine. The guide went through and banged them up pretty good. So we're gonna be getting a new turbine. Yeah, pretty messed up, but luckily the compressor side is absolutely fine, and this is the really expensive piece. These are a little pricey, but not too bad. But if you mess up the compressor, you're looking at dang near buying this turbo, almost half of it again, if you mess this compressor up. But the turbines aren't too bad. So we're gonna send it off to Boost Lab, have them freshen it up, new turbine, turbo should be good to go. All right, we got our head out. I'll show you guys a little bit closer. So as you guys can see, hold on, let me zoom and then flashlight it. So yep, as you can see, I got a big chunk of guide missing there. And then I just noticed that this one is cracked. So yeah, we need to address that. Everything else looks fine. The only thing is number one is getting the same wear as it was before, but 2, 3, and 4 look a lot better. So it seems to be 1 is doing it now, and it's kind of on the right side of the exhaust valves. But like I said, so you can see the crosshatch fine there, and it's smooth there. And there's no marks, you can't feel nothing. You know, it's completely smooth, but the hatch is missing. But we don't have any leakage, we don't have any compression problems, so I'm not even going to hand hone that. I'm gonna leave it, leave the pistons in, not touch nothing. Just get the head fixed, get the turbo fixed, slap it together, send it the rest of the season. All right, well, there you could really see the guide really broke out there. So that's what we're dealing with. The other thing I noticed is we got a little contact mark there on number one. So I went over and looked at the piston, and it looks like at some point, I mean, it's not crazy, but you see how that's a pretty sharp edge there, and that looks kind of rounded off. Like it just barely contacted right there. And that could have been from a backfire, and the valve backfired and the valve kind of popped out and just barely kissed it. Could be, rev limiter. My two-step's not super aggressive, so I don't think it would have been two-step, but it very well could have been rev limiter or traction control ignition cut. That's when the valve can backfire and the valve literally pops open when it's not supposed to, and it just barely kissed the piston. But piston looks fine. I mean, I don't think it really did any damage or anything. So, but most likely, since that valve kissed, Jeremy will probably just replace that valve. I mean, most likely we're going to just replace, at minimum, all the exhaust valves, and I'm sure he'll look over the intake valves and see how they look, maybe just clean them up. But it's not a bad idea to replace exhaust valves. I did take this valve out and ran it through the guide and see if it was bent, but it doesn't appear to be bent or badly bent. These are very strong valves. These are Optum brand, the stuff that Jeremy gets, and a very, very tough valve. I mean, obviously it sees a lot of abuse, but valve looks good. Everything here looks good. So I'm gonna run this over to Jeremy, I'll let him work him, and should have everything back together pretty quick. All right, so it is a week later. You know how I said I'm not gonna pull the pistons and do a hand hone? Yeah, I was lying. So I'm gonna do that now because I found some recent things, and let me show you real quick. All right, so factory intake, right? So when I first got these billet atomizers, they're quite massive. So let me show you guys this. This is a factory, not a factory, this is an aftermarket, but this is like your standard high impedance injector that we would typically run on the S2000. And of course, you put them side by side, they're quite the difference. So originally when I put these in, since these tips are so long, I was like, well, I can't have it sticking out too far. I was worried about it getting too deep in the chamber. So what I did was I took these old guys, flipped them around, and I've been running these like this ever since I had the atomizers. Mind you, when I had the 2600s, which are the same size as these, I didn't have this issue at all. And I kind of plumbed it up to, well, atomizers deliver a lot more fuel, blah, 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 blah. But in actuality, once you pull the pulse width back, yes, the atomizers are a big injector, but in theory, they should only be putting out what I was putting out with 2600s. So I started reaching out to some people. We've been kind of banging my head across the wall here about this cylinder wear problem. I just can't figure it out. We've been through thinking it was ring materials. We thought it was just side load. We thought the hone was, maybe it was wrong. Piston design, although the piston's not actually rubbing, it just seems like the ring is wearing. And I kept coming across the same stuff. And actually Josh Ross said this way back when we first started having this problem. He said, it looks like ring wash. It looks like you got too much fuel. It's washing the wall down and the rings are wearing the hatch off because it has too much fuel. And I'm like, but it really doesn't have a lot of fuel. Wide open throttle was good, air to fuel ratio. I've tried to lean it out. Startup has been a little rich, but nothing insanely crazy rich, blubbering rich that I would think would wash walls down. So I started researching more and I started seeing how important fuel atomization is. And then it kind of dawned on me when I got home from work the other day. I'm like, I want to see how the injectors are in the port that they're in. So check this out. So like I said, I've been running them like this, and I normally don't take my intake off very often because it's kind of a pain to get on and off. So I never really got to see how far this tip goes in the hole. Yeah. Look how deep that is in the hole. Very deep, barely sticking out. And then look at all this material. So these have a really big cone, right? When these atomizers eject. And I guarantee you this material here is screwing up our cone, and it's literally just water droplets shooting like a super soaker from here into the valve. This is how they should be. Look how much deeper they are. The tip actually sticks past the material. So now your cone, your fan, which is like an angle like that, as you can see on my finger, like that and like that, now they won't be interrupted because of how deep I was running them. Now we're gonna have a nice atomization, a nice cone fan spray down into the valve. Where here, I believe, I was getting a ton of solid fuel droplets and it was still forcing fuel in, but that ridge right there was no good at all. And I sent this to Atomizer, the photo of this, and he's like, yeah, he's like, that is not good. You cannot have that. That's gonna disrupt your fuel atomization a ton. Idle will be crappy. And he said, I guarantee you that's what's causing your cylinder wall problem. Because when you have a really fine mist of fuel, it's gonna light off and it's gonna burn really good and clean. When you put water droplets of fuel, big droplets, one, they're not gonna burn very well. And you're putting those really big droplets, you're shoving them into the cylinder, they're splashing onto the wall, and it's washing the wall down. Very, very, very fine molecule mist. Yeah, you might still get some of that on the wall, but a lot of it's gonna get burned up in the combustion process because it's so fine, it's easier to light, and you have a nice flame front where droplets of fuel, not so good. And that's why it's doing it in every cylinder. Now, one seems to be worse, but they're all doing it. And I actually had more fuel in number one, which I just remembered yesterday. I'm like, oh, I do have more percentage in number one than I do in the rest. And that one's the worst. So I think we got something going on here. So I think that's going to be the fix. I feel really good about it. Like you ever know, like when you have a problem and you're like back and forth on theories and make possible solutions, and then finally one of them just like sticks out and you're like, that's got to be it. I believe this is the problem. I don't think it's the ring material. I don't think it's the piston or the hone. I think my injectors were too deep in my intake manifold. It was causing a really bad atomization. I was getting massive water or fuel droplets, and that's what was causing my wear, only on where the fuel was spraying too. And I guarantee you, since it was hitting that lip, it was just like a waterfall of like water droplets just hitting the side of the cylinder wall. Now it's gonna be a nice fine mist right on top of the valve. It should burn way cleaner. I guarantee you this thing's gonna idle so much better now. So that was my mess up. I never took the intake man off to really see where the atomizers sat, and I should have. I just threw them in, the car ran, so I just ran it like that for, I mean, I've had those in for probably at least a year or so now, and been having this problem ever since. So has it been like costly? No, not really, but it has been a lot of like banging my head against the wall, you know, hand honing this thing, putting rings in it, thinking it was a ring issue or something like that. And this whole time, I'm like 99% sure I screwed up on the depth of these injectors. So since I found that, I am gonna pull pistons, I am gonna hone it, and we're gonna run the exact same rings. I'm not changing these rings out. These rings only have like 2 months of runtime. So in order for me to really tell if this fixes my problem, I have to put a new hatch in this because, or else, you know, I could maybe see if it gets worse, but I'm not gonna see if it really solves the problem. So it's already apart. All I gotta do is drop the oil pan and pull a piston out. And since we have Jason maybe this cool little guard, we're gonna put this to use, put it down in there. I'll still probably put some rags or something around the crank journals or around the mains and stuff. But as you guys saw in my previous video, this thing did an amazing job of keeping all the trash from falling down into the bearings. So we're gonna be putting this to work today. We're gonna hone these cylinders. We're gonna put the pistons back in. And then we just gotta wait on Jeremy to get the head done. Boost Lab has my turbo. They said they'll have it done in a week or so, and I'll have everything back. Let's go ahead and get the car jacked up, get the oil out of it, pull the pan, pull the pistons. I'm really excited too to see how these Calicoat rod bearings are doing. So we'll get to see those and we'll go from there. All right guys, we got our piston rod out. Look at these Calicoat bearings. Wow. I mean, super nice. This is the upper, so you can see starting to wear a little of the coating off, but I mean, they look incredible. Really, really nice. I mean, granted, these don't have a super long run time on them, but man, really, really nice wear. Super happy with that. And I'm putting these right back in. There's nothing wrong with these bearings. They almost look new, especially the bottom bearing. Piston wise, so exhaust side is where we're getting the rubbage. And as you can see, I mean, this is normal, some normal skirt wear down here. But as you can see, and that's discoloration. I think it's discoloration from fuel. But yeah, as you can see, that's the crown. As you can see that little mark there, that's the crown that's built into the piston. That's on both sides. But there's no scuffing, so you can see there's vertical lines. No scuffing anywhere on this piston. So it's all ring. The ring is wearing it, and it's because the fuel is getting in there, it's washing all the oil, all the lubricant off, and the ring is just scraping away that hatch. So everything looks fine. All right, we got her all out. I mean, you couldn't ask for better bearings. I mean, look at these. Absolutely immaculate looking. Even the upper rod bearing was which gets most of the force. They're not chewed up at all. A little bit of coating wear, and that is it. All the pistons look good. They all have their minimum dirt scuff that they've had in the past. This one did catch something. That happened a long time ago. I just SOS padded out, and it's very smooth. It looks a lot worse than what it actually is, but everything looks fine. So next step is to get the ball hones out, get my guard in, and give them a hatch. All right, we got our hone guard that Jason made, and that is to prevent trash from going down around the main journal. It worked last time. We tested it out of the car, and it worked really well. So let's get a hone in there and clean up these walls. All right, so you can clearly see the two that I did, and then the two that I have not done. You can see where it's wearing right in there. And this puts the hatch right back in. So it's brand new cross hatch. So I'll finish these two cylinders. Our guard is working wonderful. As you can see, it gets all the crap, and it's O-ringed. So I clean this off each time I use it. It's working really well. So yeah, so they're looking good. Look at that cross hatch there. As you can see there, all the wear. So we're really hoping that these injector is what's been causing this. And hopefully we took care of it. So we will see. All right, we're all cleaned up, and I will do one more cleaning before I put each piston in. Another really important thing is making sure that rod journal is clean before you put bearings on it. So I haven't really touched them. They look pretty clean to me, so I'm gonna kind of leave them. But what we're gonna do is clean up the pistons really good, make sure the bearing faces all look good, and then we'll start dropping in each piston. All right, guys, we are back in action. We got that fresh hone. Everything's back together, oil pan's back on. We are just waiting for our head to come back from Jeremy and our turbo to come back from Boost Lab. So once those come back, I'll do a little more filming, show you the new turbo from Boost Lab, show you what Jeremy did on the guides. I think we're gonna do new valves as well since it's out. That head's probably got 1.5 years-ish runtime on it. But I am really excited to get everything back together and see how these injectors work in the new location. I think that was totally the problem.